welcome back to the first year topic of the periodic table. The next topic that we study is the variation in the variation in the periodic properties. Electron gain enthalpy. Electron gain enthalpy. This is also named as electron affinity. Electron affinity. This is indicated with EGE. The symbol for this one is delta EGH. H stands for enthalpy, electron gain enthalpy. And this is indicated with electron affinity. When we consider this electron gain enthalpy and electron affinity, both indicate the same, but only thing is, electron affinity is only indicating the magnitude, but electron gain enthalpy should be indicated with this sign. When electron gain enthalpy is positive, it means energy is absorbed. When electron gain enthalpy is negative, it is energy released. So for any process in which energy is released, it is called delta H negative. In which the energy is absorbed, delta H is positive. So that is the only difference. With sign we indicate EGE, while only magnitude is indicating the electron affinity. Now let us first see what is the definition for this electron gain enthalpy. Suppose you consider an atom in the isolated gaseous state. Any atom X, it is not only halogen, remember that. When we add an electron for the isolated gaseous atom to give rise to isolated gaseous ion, the energy change is called as the electron gain enthalpy. Energy change, it may be either positive or negative. So that is actually called as the electron gain enthalpy or electron affinity. So it is the energy change that takes place when an electron is added to isolated gaseous atom. Isolated gaseous atom to give an ion. The characteristics of this electron gain enthalpy can be given as EGE may be positive or negative. Sometimes energy may be absorbed or sometimes energy may be released. When energy is absorbed, EGE given a positive charge. When energy is released, it is called EGE negative. The second one is this EGE indicates tendency of an atom to gain electron. So how much tendency that element will be having to gain the electron, that is indicated with this electron gain enthalpy. Higher the negative electron gain enthalpy, easier is the absorption of the electron by the element. But sometimes what happens, electron may be forcibly to be added by the supplying the energy. So in such a case, electron gain enthalpy will be positive. I will give examples for both kinds. Now for example, when an atom like chlorine in the isolated gaseous state, when it is taking an electron to give rise to Cl minus ion in the gaseous state, this delta EGH is indicated with minus 349 kilojoules per mole. Always energy is measured in terms of kilojoules per mole, because for one atom the energy released is very, very small. When you take 1 mole of chlorine atoms in the isolated gaseous state, when 1 mole of electrons are added to give rise to Cl minus ions, the energy released is 349 kilojoules per mole. But actually for this one now, electron affinity is indicated only with the magnitude, 349 kilojoules per mole. We can write. Now let us see the various factors that factors affecting electron gain enthalpy. Factors affecting electron gain enthalpy. There are three important factors on which we can explain the variation of the electron gain enthalpy. The first one is atomic radius. Atomic radius. As atomic radius decreases, electron gain enthalpy becomes more and more negative. It is because as the size decreases, the orbit in which the electron is added becomes easy to be attracted by the nucleus. That's why as radius decreases, electron gain enthalpy becomes negative, more and more negative. All the three will actually favor or act together. The second one is the nuclear charge. As the nuclear charge increases, electron gain enthalpy becomes more and more negative. The third one is electronic configuration. So this we have to explain by considering different types of configurations. Suppose for any element electronic configuration is NS2, especially for the elements belonging to second group, that is beryllium, magnesium, etc. Beryllium, magnesium, calcium, etc. Since the configuration indicates the completely filled orbital, so this is having positive. For such an element, positive electron gain enthalpy. Similarly, for an element like NS2 NP3 configuration, this is actually having the half-filled configuration. For this also, electronic configuration will be, so electron gain enthalpy will be positive. Similarly, for elements NS2 NP3 configuration, NP6 configuration, new orbit is required for this to get the electron to be added. That's why electron gain enthalpy positive. For NS2, we write alkaline earth metals. They are having the positive electron gain enthalpy. NS2 NP3, this is actually nitrogen family. Since this nitrogen family has got half-filled configuration, again to add an electron to that particular orbit, energy is to be supplied because there will be disturbance in the stability. Then when you consider this NS2 NP6, this is for noble gas. For these noble gases, since the configuration indicates the completely filled orbit, the additional new orbit is required for the addition of an electron. That's why for such an element, for these kinds of elements, the electron gain enthalpy will be positive. How this electron gain enthalpy varies across the period and down the group, along with the graphical representation of the electron gain enthalpy variation across and down the group, we will consider in the next video. Thank you.